when letting it crash is not enough. What's beyond letting it crash then? And what does this woman have to do with crashing? Let's see. I'm confused. Oh, so clean. Nice design. When it comes to computer systems, the Erlang OTP programming platform has an interesting approach to failure handling. It's also widely known under the name Let It Crash. The core idea behind it has to do with the fact that modern applications have a huge number of states that they can find themselves in. Oh yes. The more complex your application is, the more variables you need to keep track of everything. Eventually, it becomes impossible for developers to predict all combinations of state that these variables will form. That's where some techniques, design patterns come in to help you out. I like to make sure that my code is predictable and that I can implement a new feature as if I was writing from scratch. But I completely agree with this. That's what makes an experienced developer stand out. An experienced developer values simplicity and wants to make sure that the code stays as simple as possible, because the more code comes in, the more features are implemented, the more complex it becomes, the more difficult it is to work on it, and the more likely it is to crash. So apparently some developers were just not good enough and accepted that, well, let's just not bother with it. Let's just let it crash. So once your app gets into an undesirable state, the best thing you can do is to reset it and start from a fresh, well-known, and correct state. Like turning off and turning on your computer. This works amazingly well together with Erlang's property that each process has a separate memory space, allowing us to selectively reset only parts of our application. Oh, now that is interesting. Now they're trying to convince me to use Erlang, because that's big brain. Allowing us to selectively reset only parts of our application, while keeping the system as a whole running. Then we can divide the application into a tree-like structure and keep restarting parts of it until we reach the root and are forced to restart the whole thing. This concept is also known as supervision trees. If you take a look at Erlang's approach, this is exactly what a human would do. If your phone gets stuck playing a video, you will try restarting the app. And if it doesn't fix it, you might end up restarting a phone, like an idiot. Or even the router of your home internet connection. You intuitively know that propagating the failure through your home will eventually bring all devices into a state that resembles the one when you first set everything up and everything was working. I understand what it's trying to say, but I would never want to get to that point where I don't know what my code is doing, so I have to kill it and start over as a fix. Even sometimes Erlang's claims around resilience and fault tolerances are a bit overblown. I still think that it's a very powerful way to deal with failure. If my web app breaks, the first thing I do is to restart the server. If my web app, in the majority of cases, this immediately fixes the issue. While I dive deeper into the logs trying to figure out what went wrong. At least that, I thought they were not even gonna bother to check. Having this automatic restarting capability at every level of abstraction in your app will definitely help you sleep better. However, resetting the state is almost never enough. In the phone example, once the phone starts up again, you will still need to get back into the state where you stopped. This usually means finding the video again and jumping back to the right point on the timeline. We are partially reconstructing the state where we stopped, but ignoring all the other states where things might have gone wrong, like our home internet connection being broken. What a scary way to live. For humans, it's easy to approximately remember where we stopped watching a video, but for an application, it's impossible to reconstruct the state without the developer explicitly keeping track of it. And let's not even bring up external resources like files. In Erlang, this would mean that we have one process as part of our supervision tree that, for example, every second writes down how far the video got. Once it's restarted as part of a parent supervisor, it will know how to restore the state from disk. Durable execution. This brings me to a recent discovery I made. Another approach to dealing with failure that completely blew my mind. It's commonly known under the name durable execution, and is so new that most developers never have heard of it. It's an elegant solution to the keeping track of the execution problem and perfectly complements Erlang's approach. The simplest way of thinking of it is as a database for compute progression. It stores the minimal amount of data to be able to reconstruct your application's state at any time. It makes your local variables indestructible. And for any scenarios, you will not even require a traditional database anymore. Imagine if you could just start an arbitrary computation and the system guarantees that it will run until completion and all the operations will be performed exactly once. Even if your app needs to be restarted in the middle, or even if you need to stop the computation, move it to a different machine and continue. Whoa. I actually like that. I'm intrigued. Your running code suddenly becomes this tangible thing that you can look at, move, and play with. All this intrigued me. Oh, you're not the only one. Okay, you got my attention. So, all this intrigued me so much that I started working on my own engine for durable execution called Flawless. Oh, thanks, Bernard. This whole article was an ad for Flawless. So, Flawless is an execution engine for durable computation. It will run your code until completion, even in the presence of hardware or software failure. We aspire to allow builders to create amazing experiences for others. I'm a builder. And the best user experiences require complex UIs holding complex state. But trying to model all the state inside your database can be challenging. At the same time, you don't want the user to lose progress by accidentally refreshing the page. Oh yes, that is annoying. Making continuous persistence a requirement for modern applications. Flawless allows you to model this persistent state with just code and local variables, raising the bar when it comes to expressing complex behaviors inside applications. How does it work? With code and local variables. How does it work? Oh, that's the next section. Workflows in Flawless. Workflows in Flawless are written in Rust. In fact, they are just regular Rust functions. This means that they can contain arbitrary logic. But instead of native code, the functions are compiled to a WebAssembly and executed in a completely deterministic environment. The only non-determinism is introduced when interacting with the real world. Like performing HTTP requests, generating random numbers. WebAssembly requires us to explicitly handle the non-deterministic execution. We use that knowledge to persist a log of non-deterministic side effects. This means that if the execution of a workflow is ever interrupted, we can just rerun it and catch up to the same state without the need to perform the side effects again. Sounds like you need to keep track of quite a lot of things. Let me see. Here's a code example. We've got a user, Adele, comic ID, flawless random, URL, here it is, content, quote, and then a greeting. And then there's a side effect log. Rec v message, HTTP request send message, get clock time. Wow. Oh wait, there's a slider. I just noticed, I think. Hold on. Oh, it's doing something. Tag log, empty, generated, write to log, return a number. Oh yeah, that's the ID. Execution interrupted, machine unexpectedly rebooted. And it's starting a new tab, catching up, going back to where it was, and it's continuing. This makes the amount of data we need to persist minimal, and the rest is just recalculated on demand in case of failure. A nice side effect of this model is that the whole system is observable. Oh yes, it was. We can take any finished or still running workflow and analyze the exact execution path it took to get into the current state. Like a debugger, but all of the state can be kept track of. With a completely deterministic execution environment, impossible to reproduce bugs become a problem of the past. Yes, but I wouldn't try this on assembly code. Notice how flawless takes away the burden of persisting the state. You just write business logic and can be assured that all the actions are going to run until completion. Even if you need to occasionally restart the server because of maintenance, once you start the flawless engine back up, the workflows are going to seamlessly continue executing from where they stopped. Interesting. I commend this. I like where this is going. I think in a few years, they will come up with a system that reliably deals not only with app processes, but also with app data. If they have a knack for marketing, they might even come up with a catchy name for this. Maybe something like, well, it's a base for the data and it's a system to manage it. So let's give it a nice acronym, say DBMS.